Welcome to this tutorial on Kind, which stands for Kubernetes in Docker. Kind is a powerful tool that allows you to run lightweight local Kubernetes clusters right on your development machine. Throughout this tutorial, you'll learn how to set up Kind and use it to create Kubernetes clusters inside Docker containers. This is particularly useful for testing, learning, and local development without the need for expensive cloud resources or complex virtual machine setups. Kind is a tool specifically designed for running local Kubernetes clusters using Docker container nodes. Originally created for testing Kubernetes itself, it has become an excellent choice for local development and continuous integration pipelines. Instead of using virtual machines, Kind uses Docker containers to simulate Kubernetes nodes, making it incredibly fast and resource efficient. The key advantages of Kind include fast cluster creation, minimal resource usage compared to traditional virtual machine-based solutions, support for multi-node clusters, and it's perfect for testing your applications in a realistic Kubernetes environment. Before installing Kind, you need to ensure your system meets certain prerequisites. First, you must have Docker Engine installed and running on your machine. Version 20.10 or higher is recommended for optimal compatibility. Second, you need kubectl, which is the Kubernetes command line tool used for interacting with your clusters. Make sure to install a version compatible with the Kubernetes cluster version you plan to run. Finally, ensure your system has adequate resources, at least 2 GB of RAM and 20 GB of available disk space. These requirements ensure smooth operation of your Kind clusters. Installing Kind is straightforward and varies slightly depending on your operating system. For Linux users, you can download the Kind binary using curl, make it executable with the chmod command, and then move it to your local bin directory. For macOS users, the easiest method is using Homebrew by simply running brew install Kind. Windows users can install Kind using Chocolatey with the command choco install Kind. After installation, verify that Kind is properly installed by running the Kind version command in your terminal. This will display the installed version and confirm that Kind is ready to use. Creating your first Kubernetes cluster with Kind is remarkably simple. The most basic command is kind create cluster, which creates a single node cluster with the default name Kind. If you want to specify a custom name for your cluster, use the --name flag followed by your desired cluster name, for example, my cluster. Once the cluster is created, Kind automatically configures kubectl to connect to it. You can verify that your cluster is running properly by using the kubectl clusterinfo command with the appropriate context. The context name follows the pattern Kind followed by your cluster name. This verification step ensures your cluster is operational and ready for use. While single-node clusters are useful, Kind really shines when creating multi-node clusters for more realistic testing scenarios. To create a multi-node cluster, you need to define a configuration file in YAML format. This configuration file specifies the cluster kind and API version, followed by a node section where you define the roles of each node. You can specify one control plane node and multiple worker nodes. For example, you might configure one control plane node and 3 worker nodes to simulate a production-like environment. Once you've created your configuration file, simply run kind create cluster with the --config flag pointing to your YAML file. Kind will then create all the specified nodes as separate Docker containers and configure them into a functioning multi-node Kubernetes cluster. One important aspect of working with Kind is exposing services running inside your cluster to your host machine. This is accomplished through port mapping configuration. In your cluster configuration file, you can add an extra port mapping section under the control plane node. Here you specify which container ports should be mapped to which host ports. For example, you might map container port 80 to host port 8080 for HTTP traffic, and container port 443 to host port 8443 for HTTPS traffic. You also specify the protocol, typically TCP. This configuration allows you to access services running inside your Kind cluster directly from your local machine's browser or other tools, making development and testing much more convenient. Managing your Kind clusters is straightforward with several essential commands. To list all your Kind clusters, use Kind get clusters. To view the nodes within a cluster, use kubectl get nodes. When you need to delete a cluster, run Kind delete cluster with the -- name flag specifying which cluster to remove. The Kind export kubeconfig command exports the cluster's configuration to your kubeconfig file, while Kind get kubeconfig displays the kubeconfig path. An especially useful command is Kind load Docker image, which loads a Docker image directly into your cluster nodes without needing to push it to a remote registry. This is particularly helpful during development when you're frequently building and testing container images. Understanding kubectl contexts is crucial when working with Kind, especially if you manage multiple clusters. Kind automatically creates and configures kubectl contexts for your clusters, always prefixing them with Kind followed by the cluster name. To view all available contexts, use kubectl config get contexts. This shows you all configured clusters and highlights your current context. To switch between different clusters, use kubectl config use context followed by the context name, such as Kind my cluster. To quickly check which cluster you're currently connected to, run kubectl config current context. Managing contexts properly ensures you're always working with the intended cluster, preventing accidental changes to the wrong environment. Kind is incredibly versatile and serves multiple important use cases in the Kubernetes ecosystem. For local development, it provides a complete Kubernetes environment without incurring cloud costs, allowing you to test your applications in conditions that closely mirror production. In testing and continuous integration pipelines, Kind enables automated testing with ephemeral clusters that can be quickly created and destroyed. For learning Kubernetes, Kind offers a safe sandbox environment where you can experiment with various Kubernetes concepts and configurations without fear of breaking anything important. Finally, for demonstrations and proof of concepts, Kind allows for quick setup of working Kubernetes environments that can showcase your applications or ideas effectively. These use cases make Kind an essential tool in any Kubernetes developer's toolkit.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.